As we can see in the organizational chart, Ravindran is the company's manager, whereas CHERYLENE plays the role as the finance and marketing manager, and me, HARSHINI KRISHNAH, as the project manager. As we can see in the slide shown, there are three pictures. The first picture is the green-blue algae, and the second picture is the cultivation of azolla in the pond, and the last picture is the end product of our BGA biofertilizer. Actually, there are four reasons why we choose to develop BGA biofertilizer is because it can fix the nutrients in the soil, whereas it also improves the soil texture and increases the yield of plants. Therefore, it is inexpensive and can help to reduce the use of chemical fertilizer. Moreover, it uses microbes to provide nitrogen from the atmosphere directly to plants. Lastly, it helps to solubilize and mineralize other plant nutrients such as phosphate.
Good day everybody, my name is CHERYLENE and I'm here to present my part as the Finance and Marketing Manager. First off, let us talk about the target audience of BGA biofertilizer. As you know, in current times, chemical fertilizers are manufactured in a way where it contains manipulated substances with known amounts of nutrients such as nitrogen, phosphorus, and potassium. This exploitation pollutes the air and groundwater by the bodies of water. The main idea of developing these biofertilizers is because the biofertilizers are able to enhance the growth of plants, biologically activate the soil, rebuilds the soil's natural fertility, and also improve the productivity of crops by 20 to 30%. It is also able to replace 25% of the chemical nitrogen and phosphorus compared to other conventional fertilizers. This shows that conventional fertilizers are the competitors of our biofertilizers. Next, let us talk about the cost and sale price of our biofertilizers. We have estimated a total of Rm33,774.22 ringgit for the production of 500 bottles of biofertilizers. Based on this, we have decided to put a selling price of Rm40 to 50 ringgit per bottles, as the prices differ as according to the size of the bottles, which is 500 ml and also 1 liter. We would be getting a profit of 3/4 of our budget. Therefore, in order to increase our production, we are here to seek for generous investments. Last but not least, it is clear to see that conventional fertilizers, also known as chemical fertilizers, are the competitors of our product. This is simply because our product is naturally made and it does not contain certain harmful chemicals such as diammonium phosphate and excessive nitrogen that may cause harm to mankind and the environment. Next, I'm passing on to Mahendran.
Hi, I'm Ravindran. My matrix number is SD2001. I'm going to talk about the process of producing BGA biofertilizer. Azolla and cyanobacteria, which is also known as blue-green algae, are in a symbiotic relationship. Algae supply nitrogen to the fern, which provides a habitat for the algae. This relationship can be beneficial for the cultivation of these both microbes as it speeds up the process and is able to yield more product in a very short period of time. For the upstream process, these cyanobacteria and azolla will be cultured in an outdoor pond. Sunlight will be the main source of the light, which will be essential for the cultures to absorb it and undergo photosynthesis. After the cultivation in the pond, the cultures are collected and treated. The mixture is filtered through a 1 micrometer pore size filter, then treated with hydrochloric acid and pH 3. After 24 hours, it is neutralized with 12 mg per liter chlorine and incubated for 24 hours without the aeration. To remove residual chlorine, after 24 hours of aeration, it may be necessary to add sodium thiosulfate to neutralize the chlorine. For the downstream process, the treated culture is dried using the reflectance window drying method. This method involves drying purees and liquids by placing the culture over a thin infrared transparent film that acts as a window for drying. Because all three modes of heat transferred are used, culture's temperature is maintained low where quick drying happens. By this method, the desired strains in Azolla and cyanobacteria will not be affected by the hot temperature, which will be useful to produce an effective biofertilizer. After the drying process, the dried culture of Azolla and cyanobacteria are mixed together with potassium solubilizing bacteria that has been processed and dried, which is available in industries. The mixture is then shaped into a small balls with a diameter of 1 cm, and after the drying and shaping process, the product is packed and ready for market. Now let's move on to the uniqueness of ABGA biofertilizer. It contains Azolla and cyanobacteria. There are many biofertilizers that are already in the market that contains only either or one of these. The incorporation of both of these beneficial microbes makes the product effective in being beneficial for the plant growth and soil. The specialty of cyanobacteria is having the ability to fix atmospheric nitrogen, decompose organic waste and residues, detoxify heavy metals, pesticides and other cyanobiotics, catalyze nutrient cycling, suppress pathogenic microorganisms in soil and water, and produce bioactive compounds like vitamins, hormones, and enzymes that helps plants grow.
For this ABGA biofertilizer, Malaysia Organic Scheme, which is known as SOM certification, is needed to be applied. Based on Malaysian Standard MS 1529 2001, this certification process was developed by the Malaysian Department of Agriculture to identify farms that practices the organic farming.